Modern operating systems are usually multitasking, meaning that they create the illusion of doing more than one thing at once by rapidly switching from one execution to another. So the kernel manages this through the use of the processes. So the processes are how Linux organizes the different programs waiting for their turn at the CPU. So sometimes a computer will become sluggish or an application will stop responding. In this section, you will learn and we will look at some of the tools available at the command line that lets us examine what programs are doing and how to terminate processes that are misbehaving. In this section, you will learn about the ps command, top command, and you will also learn about the jobs, bg, which the jobs here will list active jobs, bg place a job in the background, fg place a job in the foreground, and kill, with this kill command you will send a signal to a process, and kill all here, kill all, you will send kill process by name, and shutdown here you will shut down your computer. Actually, I don't want to shut down right now, so let's see what happens when I talk. So actually, let's learn about how a process works. So when a system starts up, the kernel initiates a few of its own activities as processes and launches a program called init. In turn, runs a series of shell scripts located in etc here and are called the init scripts. Actually, let's terminate the shutdown process right now with C, and as you can see, we terminate the shutdown process, clear the console, and let's cd to etc here, ls, and these are our shell scripts. And some of these scripts called init scripts, which starts all the system services. So many of these services are implemented as a daemon programs, the programs that just sit in the background and do their thing without having any user interface. So even if we are not logged in, the system is at least a little busy performing routine stuff. So the fact that a program can launch other programs is expressed in the process scheme as a parent process producing a child process. So the kernel maintains information about each process to help to keep things organized. So for example, each process is assigned a number called process ID, and process IDs are assigned in ascending order. So with init always getting process ID 1. So the kernel also keeps track of the memory assigned to each process. And each process read inits and resume execution here. So, like files, processes also have owners and user IDs, and also effective user IDs, and so on. So let's actually start with viewing our processes right now. Here, clear, and here you can view the process with ps command, and as you can see, we got just 2 processes, right? So the most commonly used command to view process, and there are actually several commands, and the most common used is ps. So the ps program has a lot of options, but in its simplest form, it is used like this. So the result in this example lists 2 processes, the process 13709 and process 23501. As we can see, by default, ps doesn't show us very much, right? So just a process associated with the current terminal session. And to see more, we need to add some options. However, before we do that, let's look at the other fields produced by ps. So TTA is short for, actually, let me write that down here. So TTI is short for type and refers to controlling terminal for the process. So Unix is showing its H here. So the time field is the amount of CPU time consumed by the process. So as we can see, Neither process makes the computer work very hard, right? Actually, and as you can see here. So if you add an option like this, PSX, and as you can see here, we get a bigger picture of what the system is doing. So adding the X option, note that there is no leading dash in this X option with just an X here. So let's run it again, clear, and PSX here. So there's the X command we entered is without a dash. So, and this tells us PS to show all of our processes regardless of what terminal, if any, they are controlled by. So the presence of a question mark here, the presence of the question mark in the TTE, as I said, TTE is actually teletype. So the question mark is a TTE in this column indicates here. Actually, let me take my marker. So in this command, the question marks in this column indicates no controlling terminal. So using this option, we can list every process that we own. So because the system is running a lot of processes, PS produce a long list. So it is often helpful to pipe the output from PS into less, so for easier viewing, of course. So some options combinations also produce a long lines of output, so maximizing the terminal emulator window might be a good idea too. And in next lecture you will learn about more in PS and processes, so I'm waiting you in next lecture.